All right, this video is going to talk through the 9.5 homework that will help you on your upcoming test. And here we go. So college football records the average weight for players that can bench press as 275. And with a standard deviation of 55, 3 players think the average weight is more than that amount. So they ask 30 teammates to get their maximum bench press, and they get the data. And so here is the data. And this parentheses after it, that means there's 3 pieces of data at 205 and 3 at 215. So you'll need to manually calculate those. And you can use a calculator online or on your graphing calculator to get the average of those. So we want to conduct a hypothesis test using a 2.5% significance level to determine if the bench press average is more than 275. So to write our hypotheses, we're going to write the first one. The null hypothesis is equal to 275. The alternative, what we want to test, is greater than 275. They give us the significance level. If the significance level is not given, we'll assume 5% to 0.05. So this is an average and a standard deviation. So we're going to use a z-score. So this is a normal distribution using averages. So we're going to use this one right here. Later on, we'll use the proportion normal distribution. So this is our null hypothesis. So whatever we put in here, this is going to be data from the null hypothesis. So 275 is our average. Then our standard deviation is 55. And then our sample size is going to come into play. We're going to divide that by the square root of 30 because we're going to use 30 people for our sample size. And there we get our average and our standard deviation. So 275 and 10.04. So we take our calculator and we type those numbers in. Get our normal distribution curve. And then we need to take a look at the data we collect. So we need to take a look at all these players and we're going to calculate their average. And if you do that, I believe it's 286. Make sure the p-value is close enough. Yep, it's about right around 286. So we're going to look above because this 286 number is above 275. If it was below, we would look below. So that tells me to get a bench press of 286 or higher, it's going to happen about 13.6% of the time if we're sampling 30 random people given this data. So if it happens 13% of the time, we want to ask, is that rare? Is it rare enough to reject the null hypothesis? And 13% is not very rare. We're going to compare that p-value to the alpha. And our alpha is 0.2025. This 0.1332 is not smaller than 0.025. So therefore, we do not reject the null hypothesis. If it was smaller, then there would be enough evidence to reject it. Remember, extraordinary claims require extraordinary evidence. So if the p-value is less than the alpha, then we do reject the null hypothesis. So our conclusion is there's not enough evidence to reject the null hypothesis. We cannot conclude that the player's average bench press, bench press, is more than 275 pounds. And this one, I'll let you kind of just look it over. I don't think I'm going to talk through it all. That one we did end up calculating a p-value at 0, and we do reject the null hypothesis. And then our next one I want to talk about is involving proportions. And the next 3 are all using proportions. And for proportions, we're going to be using this normal distribution for proportions. And so it's going to be really important. This is from chapter 8 to go back and to write down this formula here, this p, and then square root of pq divided by n. Remember, p is the chance for success, q is the chance for failure, and n is our sample size. So if we go in here, let's do one together. This person believes 50% of first-time brides in the US are younger than their grooms. Performs a hypothesis test to determine if the percent is the same or different from 50%. They sample 100 first-time brides and 53 are younger than their grooms. And we want to know at the 1% significance level, can we conclude that it is 50%? We want to conclude if is it 50% younger than their grooms. So our null hypothesis is, and this needs to be a p here, proportion is equal to 50%. Well, our alternative is the proportion doesn't equal 50%. Excuse me. They say same or different from 50%, so therefore we're not going to go less than or greater than. It's just going to be not equal to 50%. And our alpha level is 0.01. This is called a two-tailed test. We need to check both sides, the bottom side and the top side, to see if those are true. We're going to go back and use our proportion distribution here. So our chance for success is 0.5. That's our null hypothesis. Then we're going to take the square root of 0.5, multiply by 0.5. Those happen to be the same. Sometimes they're not. Sometimes one's like 0.3 and 0.7. And then divide by the square root of our sample size, 100. And so our average will be 0.5, and our standard deviation will be 0.05. So we take those numbers, plug them in here, and we're going to look at the data. The data we collect says 53 are younger than their grooms. So that's going to turning that into a proportion. 53 out of 100 would be 0.53. So to be 0.53, that would be pretty common. 27% of the time, we're going to have 53% or more with that data, with brides younger than the groom. 27% of the time, we'll get 53 or more. And what we can do, since this is a two-tailed test, we need to go ahead and double that p-value. So we'll double the 27% to about 54 or 55%. So this is not rare at all. So since it's not rare, we won't reject the null hypothesis. And down here, if we wanted to look outside, we could go ahead and calculate these numbers. So the 0.53, that was 0.03 above the 0.5. So we could go below and find the equivalent would be 0.47 below that. I personally don't like doing that. I just like looking above and then doubling that, because otherwise you have to do another bit of math here to get the outside values. So we take that 0.2743 and we double it, because we're checking, this is a two-tailed test, so we have to check both sides. So we get 55%. So 55% chance this would occur. So this is not rare at all. And since we are in a not rare situation, the p-value is not larger than alpha. We do not reject the null hypothesis. So there's not enough evidence to conclude that first-time brides are younger than their grooms. And there's a few more problems on here. I'll just kind of show you these. Another two-tailed test. And then another two-tailed test. So you can go ahead and kind of review those. And hopefully that helps you. We're going to take our test next week. All right, bye.